In this video, we are gonna focus on finding the percentiles. So remember that X with the subscript alpha refers to the X value that separates a certain percentage. So on the left side of that value, we're gonna call its percentage, and on the right side, it's the also percentage, a complement of the percentage on the left, but we're calling it alpha, but really that's also a percentage to the right of that X value. So these are the formulas that tie the percentiles and the alpha together. Here, for example, says find the 80th percentile of Z. Remember, Z is your normal distribution with X equals, with mean equals 0 and standard deviation equals 1. That's the standard normal. We use a separate letter for it, Z. Okay, let's see how we can find the 80th percentile. So we're looking here at our standard normal distribution with the mean of 0 and standard deviation of 1. And so since we're talking about the X value that separates the bottom 80%, so our sign here will be switched to less than. And for 80%, that value will go into the probability value. Converted to a decimal, it's going to be 0.8. And that will correspond to the X value of 0.842 if we round it to 3 decimal. Rounded to 4 decimal is going to be 0.8416. Let's take a look at our next example. It says, assume that adults have IQ scores normally distributed with a mean of 100 and a standard deviation of 15. We're already familiar with this problem. Now it says find P with a subscript 60. So that means we need to find an IQ score that separates the bottom 60% from the top 40%. So alpha in this case is 40% or 0.4, and the percentile is 60. Question B that will be to find the IQ score that separates the top 85% from the others. So here the alpha is going to be equal to 0.85. So the bottom is going to be the bottom percentile of 15. So the 15th percentile that separates the bottom 15%. So let's do that. In order to calculate those percentiles, again, we open our normal distribution, normal calculator, and we're going to put in the mean of 100 and standard deviation of 15. And we're going to say that to the left of that variable X, we're going to have 60%. So we're selecting the sign less or equals. So to the left of that variable X is we're going to have 60%. So again, the percentage goes into this field right here, and percentage converted to the probability is 0.60. And that gives us the IQ score of 103.8 approximately. Okay, now for question B, we want to find IQ score separating the top 85%. So alpha is 0.85. We could either do that and change the sign to greater than, but I actually want to keep the sign, but instead of 80%, I'm going to put in its complement of 15% into the probability field. And that gives me 84.45. So the score of 84.45 separates the bottom 15% from the rest of the population.